Hey YouTube, welcome to my channel. Today, let's look at the maximum subarray. This is a often asked interview question, and it's the solution for this problem is a classic Canade algorithm. So today, let's look at what this Canade algorithm is about and how we can use that to solve this maximum subarray problem. So let's first look at the problem. We're given a number, and we add a number. This is array, we want to look for a subarray. So here, the important definition is to understand what's subarray. So here we have this array. Subarray means a continuous subarray like this. So if it has to be continuous, it cannot discontinued. So that's the definition for subarray. So if we look at this problem here, so we have a um, -2, 1, -3, and ideally this subarray from +4 to 1 that gave us the maximum. Even though we have a negative here, but this total sum is actually the biggest one. So that's why we need to return 6 as our result. So how to solve this problem with the Canade algorithm? Canade algorithm gave us the possibility that we can just go through one time of this array to figure out the result. So let's look at how to do that. So let me first write down this array so we can use that as an example to look the detail of this algorithm. So okay, so this is our array. So in Canade algorithm, there we have a two variable we need to use when we go through this list. The first one is current sum. This is the variable to record accumulated sum, right? So then the next variable is so-called maximum sum. So that this is the value that are gonna give us the final result after we finish the traverse. So when we start traverse the tree, we start from this point, right? And so when we see in the beginning current sum equal to 0, so when we arrive at this point, the current sum value will be -2. And then we continue the array. We come to this point. We have a +1 here. And this is actually an interesting point because uh, the current sum plus this value, we have a -1. But this -1 is actually smaller than the value itself. So this tells us that all the prefix before this value, the contribution to the sum is negative, right? So because of that, we can simply ignore everything, all the subarray before these points. We can start fresh from these elements, so we can actually assign this current sum to the value of these elements, and then continue from there. So this is a important operation, and this is actually the key point of this Canade algorithm. In order for us to get the, the maximum subarray, we always need to do this kind of comparison to make sure our current sum is bigger than the current value. If after adding this value, we have a smaller current sum than the current value, then a fresh start is required. Meaning that we need to uh, reassign this current sum to the current value. So that's the whole idea. So now after that, we continue our array. So at this point, this will be -2. So we are fine with that because this is current sum plus -3, right? So this is -2. And then when we come to this point, again, we have elements bigger because the sum will be 2 and it's bigger. Then we will have a fresh start. Now this will be 4. Then come to this point, it's 3. So we will continue that and come to this one, it will be 5. And come to this point, it will be 6. Now, when come to this point, we have actually 1. And then come here is 5. So apparently our biggest sum is this 6. And that's the subarray from 4 to 1. So this is our uh, uh, solution we're looking for. So now let's look at how to solve this in code. Let's look at the source code in this case. We actually have this first corner checking, make sure that okay the array we're given is not empty. And then if after that we will start as we mentioned, we will have a max sum and current sum. We actually use the first elements in this array. Let's say we have this 1, 2, 3, 4 array. We actually use the first elements to assign the current sum and maximum sum. Then we start from here, from the second one. So that's why in this loop we start from 1 here, right? So then, as we said, every time when we see a new value, we accumulate that into the current sum. Then we actually compare, right? Compare this value with the current value. If the value is current value is bigger than the current accumulated sum, that means the previous prefix, the contribution to our total sum is negative. So we have this fresh start. We simply ignore all the previous sum and use the current value as our current sum. So this is actually the special treatment we have to do when we have a element after the summation. It's actually still bigger than the current summation or current sum. So after that, for each of the iteration, we will check if the current sum is something bigger than the maximum sum we have seen so far. If that's the case, we simply replace the maximum sum with the current sum. And after we go through the whole list, then we can return the max sum as our result. So this is the way how you can solve this maximum sum subarray problem with this famous Canade algorithm. So this is a very useful algorithm. Thank you for watching and see you next time.